Hello everyone, so today I'm here with Damien Toner from BIM and we have a very interesting project for him to talk about and we'll just go straight into it. So Damien, could you introduce yourself and what you do in BIM, please?
Morning. So yeah, my name is Damien Toner. I work for BIM in the Development and Innovation Division. So I'm kind of responsible for working on new species and new projects within BIM. BIM is obviously responsible for aquaculture and fisheries development within Ireland.
Okay, and so the project that you'd like to talk about today, could you go into that a little bit, please?
Yeah, so I suppose in the past maybe 10-15 years we've been working on developing freshwater perch farming in Ireland. And out of that, we've developed work on what we call ramp systems. So a ramp system is basically like an outdoor recirc system. So everybody will be aware of probably the benefits of recirc and RAS. And in the past number of years, a lot of work is concentrated on developing indoor RAS systems where you've got drum filters obviously taking out sediments and the use of biofilters to reuse water. One of the issues with RAS, however, is that it's precluded from organic status. So RAS in Ireland is pretty much confined to juvenile production. And even at that, there's not that many units. Most of the farms in Ireland are traditional flow-through systems. So one of the issues that raises in current environmental legislation is abstraction and discharge of water. So BIM was keen to look at how we might mitigate against large-scale abstraction and discharge of water and how we might adapt a system to reuse water externally. So we've been working on this for a number of years, and I suppose we developed the system out of split pond systems in the US, which are used for catfish farming. So in a split pond system, water is recirculated through treatment ponds, which utilize algae to break down waste produced by fish, and then the water returns back to the fish. So we've modified the system. We tried it at a site in Sligo, at Key Water Fisheries in Sligo. It's quite successful, and now it's been utilised at a site in the Midlands in County Offaly. So the site in Offaly is at Mount Lucas Wind Farm. It's about 5.5 hectares, but the overall wind farm is 1,100 hectares in size, so quite substantial. And it's cutaway peatland, so it would have traditionally been used for harvesting peat. Obviously, peat harvesting is ceasing or stopping, and Bord na Móna, which is the state agency responsible for peatlands, is looking at diversifying its landholding. So we developed a project in tandem with them on the site in Mount Lucas. So we have a license there to farm trout and perch and duckweed. So the system in Mount Lucas uses algae and duckweed to treat the water. The fish are held in ponds, they're fed as they would be on a normal farm with organic food, held at organic densities, and the water is recirculated around the system using paddle wheels or airlifts. And so we've been trialing this now for 2 years, and the results are very positive. So we've managed, certainly for periods of maybe up to 6 months at a time, not to abstract or discharge any water. The only water being used on site is from rainfall. And yeah, it's some very positive results, which if we can develop further and make available to the industry, obviously could help them with their discharge permits.
Okay, so what's the next step for this innovation then? What's happening next?
So initially, in this environment, it's very unusual to grow fish. So the initial task was, can we grow fish? How do we do that? What fish is it suitable for? We weren't convinced that it would be the ideal environment for trout, but thankfully they've actually thrived in the system. So the next step is to really, I suppose, commercialize it and modify it so it's a bit more manageable. So although it's an outdoor system and it's quite extensive and a large site, that doesn't mean that we don't employ the same management strategies that we would in an intensive recirc system. So we're constantly measuring ammonia. We have a sensor for measuring ammonia. We measure pH constantly, oxygen, obviously, temperature. In addition to that, we do sampling daily on phosphates, nitrites, nitrates. We measure the flow in and out of the farm, rainfall, etc. The growth rate of the fish, total chlorophyll, total cyanobacteria, all the different water quality parameters, so that we can manage the site as well as possible to ensure optimum conditions for the fish. So that means you're trying to manage duckweed and algae growth, which isn't entirely easy. So if you can imagine algae outside, we're not trying to ensure it's the same algae all the time. You get many, many different species, and each of them can bring opportunities or challenges for the fish. So the opportunities are obviously that beneficial algae, as we all know, are very good, not just for fish, but also for humans. So you'll see in your health food store, you might see spirulina or different algae, chlorella. So these algae are naturally present in the system. They ensure that the fish have nearly a prophylactic benefit for the fish, so that they're not challenged by pathogenic bacteria. So that's the aim of the system, is to ensure optimum conditions for the fish. And that doesn't necessarily mean clear water, it means that it's healthy water. So it's nearly like green water. So anybody that's familiar with sea bass or sea bream culture will know that they use green water for larval culture because it's really beneficial for the fish. So it's the same methodology here. So the challenges we have are trying to maintain that, obviously outdoors, seasonal, Irish weather, winter, summer, all the different changes. And we would like to get to a stage where we have closed the nutrient loop. So you often hear people talking about closing the nutrient loop, which means that whatever nutrients are put into the system are removed in some way. So in a fish farm, obviously, we put nutrients into the system in the form of fish food. And we take those nutrients out by way of fish biomass. So when we harvest the fish, we take nutrients out. There is also nutrients there in the form of sediments. So on this site, we have aeration, which helps break down the sediments. So you get lots of natural zooplankton and bugs and insects, which obviously the fish can eat as well. So that's a benefit for the system. And we also harvest the duckweed. So if you can imagine, Georgia, with algae, it's quite hard to harvest algae because it requires drum filters, freeze dryers, things like that. But with duckweed, we can harvest it by using a skimmer. So the fish excrete ammonia, the duckweed uptakes ammonia directly, and then we harvest the duckweed out of the system. So we're trying to close this loop, so that whatever nutrients we're putting into this system, we're taking out somewhere along the line. So future work is going to concentrate on how we do that better or improve it. One of the options we have is that the duckweed has quite a high protein content, about 40%. So we're looking at utilizing that for animal feeds. It could also be used in areas in pharma, in cosmetics. So it's quite an interesting product. You'd be aware as well, there's a lot of interest in alternative proteins, and duckweed is a potential alternative protein, either as a digestate for insects or directly as an additive in feeds. Mm-hmm. So that's the next part of the project, is really to try and improve our nutrient removal in terms of harvesting duckweed and utilizing it for another product. And then we can say we've pretty much closed the nutrient cycle. So for the broader industry, how this might manifest is that we come up with a methodology for treating waste from every fish farm, which ensures that they can meet their environmental obligations, but maybe also in future increase their production, because they will have proven that they're not having any detrimental effect on the environment. And it's a part of a broader work program on bioremediation and how we address the challenges that the industry is going to face, particularly in terms of water abstraction and discharge.
Okay, so what's your timeline for this? I mean, if there's a farmer that's interested in replicating this kind of work, do you know when you might be able to provide guidance or recommendations for them?
So the project is running until September of this year. We're hopeful to extend it for another year as well to fine tune some of the issues. The farm is available now for any farmer to come down and have a look, and we can show them the system. And we're hopeful that on the back of that, we will provide a guide or an information booklet, which will be available for farms so that they might employ some of the methodology we're using in future either aquaculture or discharge license applications. So I think it's very much about having a practical example that somebody can come down and see what's been used and maybe think about how they might employ that at their site. And obviously BIM, its job is to disseminate the information, but also to facilitate farmers, you know, as they go through the licensing procedure or discharge licenses and helping them. And we're very keen that this is a practical example of how that's done. So the first step is to make sure that it works properly and then to disseminate it.
Excellent. Okay, so if someone would like to come and visit, how would they sort that out then, please?
Yeah, they just get in contact with me and BIM, and we'll arrange that. And we'll take them down and show them around the site. And yeah, hope it's not raining or too windy. It's a wind farm, so it tends to be windy, but the Midlands of Ireland is a large open space, and I suppose not traditionally an area that you would expect aquaculture to be happening. But from a space point of view, it's fantastic to have so much space to have a farm. And yeah, so if they contact me, Georgia, we can organise that.
Excellent. All right. Well, I think that's all the questions I had. Is there anything else you'd like to add, or do you think that's everything?
No, I think that's, I suppose, obviously, you know, BIM is passionate about aquaculture and firmly believes that it provides so many of the solutions to food production, sustainable food production within Europe. And I think it's important that not only farmers are ambitious, but that we're ambitious about how we can expand the sector and improve its efficiency. And you know, this isn't greenwashing. This is you know, really trying to improve the efficiency of farms, and it's really important. It's really important that we help farmers achieve their ambitions.
That's great, and I think it's very exciting. I think that's it then. So
okay.
Thank you very much indeed for your time.
No problem. Okay.
Speak to you soon.
Thanks, Georgia. Bye.
Bye bye.